make up the function. Okay, for 61, we're back to two regions, two different, the function is broken up into two pieces or two sections. The line that's going to divide the two sections is the line x equals -1. The domain tells you that. So, -1, I'm going to draw a dotted line. Okay, and then I'm going to replace the x with -1 up here. So 2 times -1 is -2 plus 1 is -1. So the ordered pair is going to be -1, -1. It's closed because it says it equals 2. The slope is 2, so I can't go up to right 1, I have to go down to left 1. So I end up right here. Okay. Connect the points. Okay, that piece is done. For the other one, it's going to be replacing the 1 here, replacing the x with 1, with -1. Then you square a -1, you get a positive, so 1 minus 2 is -1. Okay, so it's a parabola. The vertex is 0, -2. So it goes something, oops, forgot to change the color, sorry. Alright, so for 62, the boundary line is going to be x equals 0. So go ahead and do that. To the left of the green line, we're going to graph 3 plus x, and to the right of the green line, we're going to graph x squared plus 1. So replace the x with a 0 up here. So 3 plus 0 is 3. So 0, 3 is going to be an open dot. The slope is 1 because it's x, so the slope is 1. So I have to go down 1, left 1, takes me in that direction. And then the second function is a parabola, x squared plus 1. It's a quadratic, so the shape is a parabola. Replace the x with a 0, so 0 squared plus 1 is 1. So change the color this time. So it's going to be 0, 1. It's closed. And goes up from there. Okay, so there's a graph for 62. Okay, so 97 says a function with a square root cannot have a domain that is a set of all real numbers. Okay, now we've seen examples in class, in the do nows and some of the homework, other previous homework, where you do have a square root and the answer for the domain is all reals. So this statement is false. I'll give you a couple of examples, or one should suffice. So if you have like f of x equals square root of x squared plus 9, let's say, the domain is all reals even though you have a square root, because no matter what x is, even if it's negative, you're going to square it, so it'll be positive. So the smallest value of x is 0. Of x squared, actually, is 0. So 0 plus 9 is positive. So there's no way you're going to have negatives inside, no matter what value of x you choose. Okay, so false is the answer, and then an example, like a counterexample for that statement, is the one I have on the screen. So 98 says that it is possible for an odd function to have the interval 0 to infinity, including 0, as its domain. So you have to remember what an odd function is. Remember, an odd function says, I'll wait for the bell. Okay, that if xy is on the graph, then negative x, negative y is also a point on the graph. So that doesn't, that interval that they gave you doesn't allow for that. for opposites. It's only counting the positive numbers and 0. So this is another false statement. Okay, and the reason is the one I just wrote on the screen, because if x, by definition, an odd function, if xy is on the graph, negative x, negative y has to be on the graph also. So it's false. Alright, so number 110, I forgot to put the number. So number 110 says that half of the graph of an odd function is shown, and it's what you see on the screen right now. For part A, you have to sketch a complete graph of the function. So remember, if 1, 2 is on the graph, then -1, -2 has to also be on the graph. So I will -1, -2, use the same color, and so connect, whoops. Okay, so there's a complete function right there. That's part A. Part B, find the domain and range of the function. So remember, for domain, we go across from left to right, and on the leftmost thing we encounter an arrow as we go across, and then on to the right we encounter another arrow, and it's continuous all the way through. There are no gaps. So the domain would be all reals. Okay, the range, you go from the bottom to the top. So from here. Now you might say, oh, it's that's my lowest point, but remember, this arrow indicates that it goes on forever to the bottom, and this arrow indicates that it goes on to the top forever. Okay, so then this one is also all reals for the range. Okay, for C, identify the open intervals on which the function is increasing, decreasing, or constant. So increasing, remember, when we read a graph, we always read it from left to right. So as I go from left to right, from here to here, it's decreasing. The value is going down. From -1, -2 all over here, it's increasing. Okay, the value is going up. And then from 1, 2 on to the right, the value continues to decrease. So you would write from -infinity to -1, because I'm going by the x values, it's increasing. I'm sorry, decreasing. From -1 to +1, and this is an open interval, okay, it's not an ordered pair. So I'm saying from here to here, okay, it's increasing. And then from 1 to infinity, so that's from here to here, it's decreasing. Oops. Okay, and then find any relative minimum and relative maximum. Okay, well this graph doesn't have like actual max or min, because this goes on forever to the top and this goes down forever to the bottom, but relative minimum and relative maximum it does have. If we look only at a portion of the graph, like for example, if we choose this section right here, this up here would be the relative maximum. If we're looking at this section right here, this would be a relative minimum. Okay, so relative max at 1, 2, and relative min at -1, -2.